Hello everyone, let's talk about another medium problem on Leetcode today. Filling bookcase shelves, Leetcode 1105. In this problem, we are given an array of books with dimensions, thickness and height, indicating the thickness and height of the book. We are also given an integer shelf width. Then we want to place these books in order onto bookcase shelves such that we have a total width shelf width. We choose some of the books to place on the shelf such that some of their thickness is less than or equal to shelf width, and then we build another level of the shelf of the bookcase so that total height of the bookcase has increased by maximum height of the book we just put down. We repeat this process until there are no more books to place. Note that at each step of the above process, the order of the books we place is the same order as the given sequence of the book. For example, if we have an ordered list of 5 books, we might place the first and second book onto the first shelf, third book on the second shelf, and the fourth and fifth book on the last shelf. Then we have to return minimum possible height of the total bookshelf after placing all the books in this manner. Then in example 1, we can see that we are given 7 books. Let's number them 1, 2, 3, 4, 5, 6, 7. Then we can actually place the books in following order to get the minimum height of the bookshelf. So we can place first book in the shelf 1 and then rest of the shelf can be empty. Then we place book 2 and 3 in shelf 2 of dimension 2 by 3. That is width is 2 and height is 3. And that actually adds 3 to the height, right? And here the height is 1. And then in the last shelf, we put all the remaining books. There are 3 books, 4, 5, 6 of height 1, but there is 1 book of height 2. So that's why the height here is again 2. And that's how we get 6 as an answer. And note that this is not a greedy problem, because if we solve this problem greedily, then the height will be 8, which is more than minimum height of 6. For greedy approach, we will try to fit in as many books as possible in the shelf. Then because the shelf width is 4, in first shelf we can actually keep only 2 books, 1 and 2, and the width of them become 3. We can't add book 3 because otherwise the total book width will be 5, which will be more than 4. So then we go to the shelf number 2 and we fill in book 3, 4 and 5, and this shelf will be full. And then in last shelf we put in remaining 2 books, 6 and 7. So because of this, the height will become 3 plus 3 plus 2, which is 8. So that is not the best answer. So we have to use dynamic programming to actually solve this problem. So let's come up with a recursive approach first. For recursive approach, what we can do is we can actually try to place as many books as possible on the current shelf, similar to greedy approach, but with a change that as soon as we keep a new book on the shelf, we also try to gauge the minimum height by keeping the remaining books on the next shelves. And at each step, whatever will be the minimum, that will be our answer. And now let's take example 1 to understand it better. In first shelf, we can either keep book B0 only. In that case, height of the shelf will be 1 and width used will be 1. Or we can keep both book B0 and B1. Then height of the shelf will be 3 and width used will be 2. We can't keep 3 books together, that is B0, B1, B2, because otherwise we will violate the shelf width. So those are the only 2 cases. And now for these 2 cases, we try to find the minimum height by keeping remaining books in the next shelves. Now we go with case 1 where we keep only book B0 on the first shelf. Then when we go to shelf 2, we have 2 options. We can either keep book B1 or we can keep books B1, B2. Note that we can't keep book B1, B2, B3 because otherwise we will violate the shelf width. And now when we keep book B1, our width and height will be 2 and 3. And similarly, when we keep book B1 and B2 on the shelf, then our width and height will be equal to 4 and 3. And again, we will try to get minimum height by keeping remaining books on the next shelves. And now we come to shelf 3. Now after B1, we try to keep only book 2 on shelf 3 and repeat the same process. But let's come to second part in the shelf 2 where we kept books B1 and B2. And then we go to the next step. And again, in shelf 3, we try to keep book B3, then book B3, B4, book B3, B4, B5, and finally book B3, B4, B5, B6. And note that we never violated the shelf width. And this also brings us to the base case. So our base case is when we have kept all the books in the shelf. And at that time, we will return the height. That height may or may not be minimum. And throughout the DFS, we will try to figure out which height is the minimum. In this case, we will return height equal to 2 and go back to previous level. Similarly, for this case, we have 3 books in this shelf. And then we go to the next level where we keep book B6, which has height equal to 2. And that is the only case. And then again, we have placed all the books. So in that case, we will return 2. And now when we add the height from shelf 4 to shelf 3, it will become 3. but it will be rejected because we already have a height equal to 2, which is less than 3. Similarly, we will continue with the rest of the DFS. And here we can see that we will get a minimum height equal to 2. So we will return. And now at this level, we can check our height was equal to 3. So we will add 3 plus 2 equal to 5. And similarly, we go up to shelf 1. And here we had height equal to 1. And then we add it up and this will be equal to 6. So similarly, we will continue with the rest of the DFS on the right, but we will get height more than 6. So in the end, we will come to know that our minimum height was equal to 6 and that will be our answer. And note that there are overlapping subproblems as well. For example, for book B2, we can see that whether we keep the book B2 on shelf 3 or shelf 2, minimum height of the remaining books on the next shelves will be same. So we are solving the same problem again and again. And for this, we can actually use memoization. Now let's jump into the code part. So let's first solve this solution in a recursive way, and then we can introduce memoization. So first thing we will do is like we can start with the DFS function. So for that, we will need the books, the shelf width,
and the book index for which we are running the DFS.
we will start from book 0. Now let's define the DFS function. This DFS function is returning the minimum height of the shelf when we start placing this ith book. For us, the base case is if we have reached the book's length, that is, we have placed all the books. In this case, we will just return 0 because placing any book more than the number of books will return shelf height equal to 0. So now we will define our current width as 0 because we are freshly placing this book on the new shelf and our height is now equal to 0. And let's define our min height that we will return at the end of this function. Let's initialize it with integer.max value. And now we can actually loop over the books and try to place them. As soon as we place the book on the current shelf, we will actually increment the current width
by this book's
width. If width is more than shelf width, we will break out of the loop and return the minimum height. And if not, then we will try to see what is the maximum height we have seen so far for the books, because that will be the height of the shelf. And then we will try to calculate our min height by calling the next level of the DFS. So it will be mat.min of min height we have seen so far, or we add the current height and do the DFS on the remaining books by again placing the next book in a fresh shelf, in a new shelf. And once this is done, we will just return the min height. So that's it. I think let's run this code.
Okay, there are some typos.
I should place 0 here and then I should return semicolon here. Hopefully those are the two errors, and also the width has a spelling issue. Now let's run this code again. Cool. But when we submit it, we will get time limit exceeded, of course. Now to fix it, we can actually use memoization. For that, we just need map. So the key will be the index and value will be the minimum height that we have got from that book. And then what we can do is at the start of the DFS, we will check if the key is already present in the map. If it is, then we will just return the value. Otherwise, we will continue with the rest of the DFS. Similarly, at the end of the DFS, we will actually store the minimum height for that index in the map. That's it. Now let's run this code again. Hopefully there are no typos. Let's submit this code. Cool. In terms of time complexity, it will be O of 2 to the power of n for the recursive solution, where n is the number of books, because for each case we are choosing whether we have to take book on the current shelf or on the next shelf for the minimum height. And in terms of memoize solution, we are actually saving those recursive calls, but we are still running a nested loop because for each book at the next level, we are actually running the loop on the remaining books. So that's why the time complexity will be O of n square here. And in terms of space complexity, it will be O of n because we are using recursive stack in both recursion and memoize solution. Because in recursion, we are using recursive stack, and in the memoize solution, we are using recursive stack as well as the map to actually store the values for n books. So that's it. I hope this video was helpful to you. If it was, please like and subscribe. The code link is in the description below. I've also added bottom-up dynamic programming solution as well. Have a nice time. Thank you.